Relations and functions. Relations and functions. That's section 4.1. So section 4.1, the goal of this section is to learn about relations. What is a relation? Learn about domains, ranges, functions, and the vertical line test, which helps us determine whether our given equation is a function. We want to learn, or our given graph is a function, same thing. Function notation, that's what we want to learn. We want to learn about function evaluation, and we want to learn about the implied domain of a function. Okay? So you have a lot of new terminology that you have to remember. So if you have an index card or if you have a sheet where you're adding new terminology, make sure you update it. Okay? So let's start out with a definition. Let's start out with a definition. A relation is a set of ordered pairs. Are we good on what ordered pairs are? Yeah. Yes. What does an ordered pair look like?
0,
0, 2, but on the outside we have parentheses, right? Parentheses, 0, 2, close parentheses, right? That's an example of an ordered pair. So a relation is a set of ordered pairs, meaning there's more than one ordered pair in that set. Okay? Any set of ordered pairs automatically relates the set of first coordinates to the set of second coordinates. And these sets have special names. The domain of a relation is the set of all the first coordinates. That's key. The domain is the set of all first coordinates. And the range is the set of all second coordinates. Okay? So, in example 1, we want to, for each of the following relations, we want to determine the domain and the range. We know that the domain is the set of what? First coordinates. So when we look here, we have these ordered pairs. S, let me read it to you. S is the set of all ordered pairs consisting of 0, 0, -5, 2, 3, 3, and 5, 3. We want to determine the domain. The domain is the set. So when we say set, mathematically we need to write what? Parentheses? Or yeah, the curly brackets. We want to write the curly brackets, or the squiggly things, the curly brackets. So we automatically do this because we want to say set. And then we know it's the set of all what? First coordinates. Good. So we look at our ordered pairs and we choose which coordinate? The X. So tell me what our domain is. The set consisting of.
Do you want us to go in order?
Yeah, I want you to go in order, but I'm telling you how to read it. The set consisting of. I love it. Come on, don't try to outrush people. 0, go ahead. Yeah. 5. Good, y'all. Very good, all of you. Excellent. What is our range? Say what? The set consisting of, or the set with elements?
The set consisting of 0,
Yeah.
2, 3, 3.
Do we need to write 3 twice?
No.
Because it appears once already. That's a good thing. That's a good thing to actually do. We first initially included 3 twice, but 3 already appears. So because it already appears in there one time, we don't need to write it again.
So why you write -5? Wait, you gotta write.
One was negative, one was positive. That's a good question. No questions are dumb. Let's not do that. No questions are dumb. You ask all your questions. They're not dumb.
Does it matter, like, if you put least to greatest, greatest to least? Or are you not grading for that?
I'm not looking for that. What other questions do you have? Okay, that is part A. you may have relations that are set up a little bit differently. Watch it. U is the set of all, what's this symbol?
Pi.
Right. U is the set of all pairs, pi, comma, y. What's this bar?
Absolute value.
No, it means whenever we have it in a set, it means such that. If we have two of those bars around an expression, that means absolute value. So let me first help you interpret this. This means we know different color, I'm explaining something. So this means the set. That's an S. The set of all. Here we have the ordered pairs, pi, comma, y. This bar means such that. Some people will write, instead of writing this that I've given you, some people will write pi, comma, y and use the colon. The semicolon. That's not a semicolon, it's just a colon. Such to mean such that. Some people will use this instead of a bar. I tend to use the bar. Okay? So it's the set of all ordered pairs, pi, comma, y, such that y, this means belongs to or is an element of. This means belongs to or is an element of. Is everyone familiar with this notation? We used it before. It might have been a while. This is the set of rational numbers. So Q is the set of all rational numbers.
Is that a one that's top to Q?
It's a line. That's a good question. There we go. So it's the set of all A over B, where A and B are integers. Integers. Okay? So the set of all rational numbers, fractions. Are we good?
Can we do a crash course on the setup thing?
Say it again. Can you do what?
A crash course on how to write a
The squiggly brackets? Some people, okay. So, no, because a lot of people ask questions about that. And so it's like you're doing a parentheses. Try to put two parentheses together. That'll work.
You put a little booty
No, I can't repeat that. We're recording this, right? For y'all later. For y'all later. We're recording this for y'all later. So you can do that. I mean, I tend to do that and put something like that.
Like, you know, the girl we used to draw in elementary, like.
That works
Y'all
too.
know what I'm talking about.
That works
Bird,
too.
just, like, turn your paper to the side, draw a little bird.
A parentheses with a caret or arrow in between. So this, and then that. You know what I mean?
Yeah.
This, and that.
Okay.
And less than, or less than. Parentheses and a less than in the middle. Are we good? Okay. All right. So let's stay focused. But that's a good question because a lot of people ask, how do you write that? Okay. So let's read it. This is the set of all ordered pairs, pi, comma, y. I'm listening. Such that y belongs to the set of rational numbers. Let's do it again. This is the set of all ordered pairs, pi, comma, y, such that y belongs to the set of rational numbers. What does that mean? Y is a fraction. Y is a rational number. Y looks like this. Are we good? Okay, so what's our domain? Hey, it's the set consisting of pi only. Excellent. Very good. Pi is the only element in that set. You're right. Because if you write down an ordered pair from this set, the only thing that's changing is what? Y. Very good. The only thing that's changing is Y. Pi is constant. Pi is going to remain the same. Pi is going to be in every ordered pair as your x coordinate. The only thing that's changing is Y. What's your range? The set consisting of Y, that means you're telling me there's only one Y.
No, all rational numbers.
The set of all rational numbers. Very good. The set of all rational numbers.
You don't have to put that in.
No, because that notation by itself means the set. So this notation by itself means the set of all rational numbers. Another way you can write it is the set of all Y such that Y is a rational number. Either one of those is acceptable. What questions do you have? What questions do you have here? Okay, very good. So notice what we did was we first made sure that everybody understood what the notation meant. After you understood what the notation meant and you understood how to read it, identifying the domain and range was a lot simpler for you. Okay? Make sure you take the time to go through and understand that. We got one more part to this example. Here, you can write this notation or you can write the set of all Y such that Y is a rational number. C. You have x equals 3. Graphically, we know this is a what?
Horizontal. But it's the
Say it again.
vertical.
It's a vertical line, right? A vertical line going through x equals 3.
Yes.
Not horizontal, vertical, right?
I know what it looked like on the graph.
We got to make sure our descriptions match what we know. That's not y equals, that's x equals. What do we know about our domain?
It's 3.
We ain't got.
It-
Oh, okay. I'm like, what?
We do have one, and it's what?
3.
3. How do we write it? Do we just write 3? The set with consisting of the element 3. You got it. Say it again. Would the range be 0? That's a good question. How are you determining what the range is?
That ain't what. Buyer.
Say it again. Go ahead. Let Ashton finish her thought.
Oh, no, you can go. Are you sure? Yeah, you
Okay, go ahead, Haley.
can. Okay, so when you take the graph, like when you take your mesophone and you plot it, you get a coordinate. The word is 3, 0. And the domain is your x, your range is your y. So your range is going to be 0 because when you get your coordinate.
So what you're saying is, if you take this point was 3, 0. And you're saying that the range is going to be 0. Is that what you're saying?
Should be? Yes.
If that's what you're saying, then you're saying that you're only picking up this point. You would not have the rest of these. You would only have this point.
Would that be vertical?
Say it again.
Would it be all rational numbers? No, I'm just kidding.
All rational numbers? What kind of numbers are you picking up from here?
All real numbers.
All real numbers. Good. So what you're saying here is that you can have any y value and x is always 3. So whenever you want to say you're picking up any number on this line, you're picking up any real number, because to make up the XY plane, you took the real number line, and this is the real number line as well. So that means if we can pick up every number on the real number line, that means your range is the set of all real numbers. The way we write the set of all real numbers is this. Yeah, you remember how to do that. The double. Good. So the set of all real numbers. I didn't hear that. What was that?
She said that R cute as heck.
Yeah, yeah. Draw the regular number and then draw a line beside it. See? Draw the R. So draw the R and then draw R right there. Or on the inside. Okay? What questions do you have here?
It wouldn't have been undefined, because I know for like one of the last.
Undefined means you're looking for what?
The slope.
Slope. It's a good question. I want you to ask your questions because you're trying to connect ideas, right? And whenever you're trying to connect ideas, we need to confirm, or we need to either confirm or not confirm what's happening, right? So we have to ask questions to get that clarification. What other questions do you have? Okay. Remember, if you need to send a message, go out in the hallway.
You don't have to put the R in the curly bracket.
Say it again.
You don't have to put the R in the curly bracket.
The question was, do we have to put the R in the curly brackets? And the answer is no, because by itself, it means the set of all real numbers.
So the only thing that goes in curly brackets are numbers.
Our numbers. Our numbers. Yes, you got it. Or whenever we're generalizing a statement. Like, what other questions do you have? Okay. Definition. A function is a relation. So you already know a function has what? A function is a relation. A relation is a set of what? Set of ordered pairs. You got it. A function is a relation. A function is a relation. So a function is a set of all ordered pairs with certain properties where you can identify your domain and your range. Okay? So a function is a relation in which every element of the domain is paired with exactly one element of the range. That's important. That's very important. Every element of our domain is paired with exactly one element of the range. A function is a relation in which every element of the domain is paired with exactly one element of the range. So if you have, we'll go through examples. Not yet. Okay? Equivalently, a function is a relation in which no distinct ordered pairs have the same first coordinate. That's another way of saying this. Every element of the domain is paired with exactly one element of the range. No two distinct ordered pairs have the same first coordinate. So if you had a function that was a relation of ordered pairs, and this appeared in this set, it's not a function.
Because the x's repeat, right?
Because the x's repeat. That's one way of looking at it. Yeah. Yep. Because 5 goes to two things. Think of you holding a ball, right? Or in this case, if I have my water bottle, which I'm not going to throw at anybody, but if you have this water bottle and I tell you, I want you to give it to Kelly and Ashton at the same time, is that possible?
No.
Because I don't know who to give it to first, right?
Yeah.
If I know who to give it to, then that makes sense. That's a function, right? But if I ever get confused on who to give it to first, then that's not a function. Okay? So, exactly every element of the domain is paired with exactly one element of the range. Okay? Theorem. The vertical line test. If a relation can be graphed, so now we're thinking of the graph of what we have. If we're looking at the graph of a relation, if this is graphed in the Cartesian plane, the relation is a function if and only if no vertical line passes through the graph more than once. So, if we graph this line and we take a vertical line, think of this red as a vertical line that we're just using to pick up and move across. Does it pass this blue line more than once?
No.
I heard yes, I see a lot of no's.
No.
No, because it doesn't cross this slanted line more than once. So it passes the vertical line test. So this relation, whatever this line is, would be a function. So it passes the vertical line test. And I'm going to go through examples so you don't have to really write this. I'm just doing it right here so you can know what's happening. This is a vertical line test. It passes the vertical line test, is a function.
Can you write an example of if you didn't pass the vertical line?
Absolutely.
A circle.
A circle, very good. A circle. It does not pass the vertical line test. If you take this line, it touches here and there. Does not pass. So this does not pass the vertical line test. And is not a function. What questions do you have? Okay, so example 2, part A. Determine whether or not the relation is a function. Determine whether or not the relation is a function. If it is not a function, identify two ordered pairs with the same first coordinate. So in part A, I've given you U is the set of all ordered pairs 4, 5, 2, -3, -2, 1, and 4, -1. Determine whether or not this relation is a function. You have 1 minute, discuss it with your neighbors. And if it's not a function, identify two ordered pairs with the same first coordinate. You have 1 minute. You have 1 minute.
Yeah, I think, right?
Your question was, do you have to what?
Write it in the little brackets, the little squiggly brackets.
No.
No?
No.
No. In 4
You should be working on this. Check in with your neighbors. As you were telling me, this relation is not a function? And what are the two order pairs? 4, 5. Very good. They have the same first coordinate. So that's why this relation is not a function. You got it. What questions do you have? Okay. There you go. Uh-oh. B. I've given you the graph of a, you need to go. So B, I've given you the graph of a relation. I want you to determine whether or not it is a function. What should you use?
The vertical line test.
Use the vertical line test. I'll give you 30 seconds to discuss it. Is the relation in B a function?
Yes.
Yes? Everybody agree? How many say yes? Raise your hand. How many say no? How many don't know? Okay, so majority gets it. This is a function. And nobody raised their hands for no or don't know. Okay? So if you take a vertical line, this is me just drawing this for the purpose of saying, okay, if you pick this red line up, move it to the left or to the right, it does not cross this more than once. So it passes. Just a second. This passes the vertical line test. Is a function. Go ahead, ask your question.
If it was flipped like up, would it still pass the vertical line test?
Sure would. What's the shape? Do you know this shape? The name of the shape? Very good. This shape is a parabola. This shape is a parabola. So the shape, yeah, I hear different pronunciations. This shape is a parabola. It's a parabola. So the question was, if the parabola faces up instead of down, is it still a function? Absolutely, because it still passes the vertical line test. So if you take a vertical line and move it to the right or the left, then it still passes it. Passes it being the vertical line test. So yes, it is a function. What about part C?
No.
No, it's not. Very good. So not a function. And the instructions are, if it's not a function, give me 2 points.
1 and 3. Wait.
I heard it. 1, 3, and
1 negative 3.
and 1 negative 3. Good. What questions do you have? What questions do you have? So what I'm going to end with is function notation, because this is worth you taking the time to go through before we meet again. Okay? So, function notation. This, many people kind of butcher it, so let's make sure we put an effort not to do that. Okay? This is read as f of x. This, f parentheses x close parentheses, is read as f of x. Not f times x. What?
F of X.
So, okay, so this is read as f of x. That's function notation. Y equals f of x is the actual function. This is the function. So, for this example, for y equals 2x minus 4, y is the dependent variable because it depends on what variable? X, right? X can stand by itself, so x is what variable?
Independent.
Very good. X is the independent variable. And then if you want to rewrite the function in function notation, remember we're taking this function and writing it in function notation here. We get this is the same thing as f of x equals 2x minus 4. So whenever you have a function in function notation, this is your what variable? Y, your good, which is your dependent variable, and x is your what variable? Independent variable. Make sure you focus on that. Make sure you understand that, and make sure you understand relations before next class, because we're going to build on that. Have a good one. Look for an announcement in Canvas about your quiz. Okay? It's not posted there yet. Have a good day.
You too.
Thank you. All right, so let's continue. Example 3, we want to rewrite the following relation as a function of x. Then evaluate the function at x equals -1. We want to rewrite the following relation as a function of x. Then evaluate the function at x equals -1. So let's begin. So here, let's combine like terms. What do you want to do first?
Move the x squared.
You said move x squared over?
Mm-hmm.
Okay, so let's subtract x squared from both sides to get y equals what? It'll come back on. I moved the cord.
Y equals
Okay, so you said y equals negative 5x squared plus 3. Oh, come on. Plus 3 plus 2y. Everybody good here? Okay, so very good. So now, what do we want to do? Subtract 2y? To get what? To get what?
negative y equals negative 5x squared plus 3.
Good. And now what?
Divide by negative 1 or negative on the y side.
Good. Divide both sides by negative 1 to get what?
Y equals 5x squared minus 3.
Minus 3. Good. And when it says rewrite the following relation as a function of x, instead of y, we need to write what?
F of x.
You got it. So we have f of x equals 5x squared minus 3. So we've done the first part of the instructions for our example. We've rewritten the following relation as a function of x. We've done that. Now what do we have to do?
Evaluate sub for
Sub x equals negative 1 into your function and evaluate. Both of you are correct. You got it. Do you need a minute to try it? I'll give you 1 minute to try it. Check in with your neighbors to make sure your neighbors have it as well. The way we write that is we're finding f. We're finding f of negative 1. That's what you're finding. What are you all getting?
2.
2. Very good. You should get 2. So, substituting negative 1 in, I see your hand. Give us a second. So you have 5. So we have 5 times negative 1 squared minus 3. So this is 5. What is negative 1 quantity squared? 1. Good. Minus 3. That's 5 minus 3, which is what?
2.
Good. It's 5 minus 3, which is 2. So this is boxed, and f of negative 1, is equal to 2. What questions do you have?
I was going to ask, what does it look like in a
The question is, what does this look like in an ordered pair? Yes, go ahead. Negative 1, what's in between? Comma 2, excellent. Because x is negative 1, and you solve for y to get y is 2. It's a good question. It's good to make that connection. Very good. What questions do you have? Yes. Speak loud where everybody can hear you.
What defines something as a relation?
What defines something as a relation?
Like,
It's a
this equation, like how does that make it a relation? Is it an equal sign?
So a relation is a set of ordered pairs. So a function is a relation. So because this is a function, we know it's a relation. It's a set of ordered pairs. You can get many ordered pairs from this particular function. We just chose one. We found negative 1 comma 2. But you have many ordered pairs that go with this. That's why this is a relation.
So does it have to have an x and y in the equation?
So the question was, in order for you to have a relation, does it have to have an x and y in the equation?
I don't think so. Because
Because you have what kind of lines?
Vertical, horizontal.
Vertical and horizontal lines. So you do not necessarily have to have an X and you do not necessarily have to have a Y, because it may be the case where X is 0 or Y is 0, but you still can have a function. You still have a set of ordered pairs. Your ordered pairs just have a fixed X coordinate or a fixed Y coordinate.
So is there like a time that you can tell that something's not a relation then? Or is it like most things are related?
If it's not a relation, then what do you know about the X coordinate?
It's 0. It's undefined.
No, it's not that it's 0 or undefined. The X's don't repeat. Very good. The X's don't repeat. Remember whenever we went through this example where we have a set of ordered pairs and then you had to determine whether that relation was a function or not based on ordered pairs that were given, and you had to look at the X coordinate to see if the X coordinate was repeated and went to different Y values. If that was the case, you did not have a function or you did not have a relation. Good questions. What other questions do you all have? Does that make sense now? Okay? All right. Good. So now let's continue with our function notation understanding. This concept that you'll see in part B is called the difference quotient. This is called, in part B, the difference quotient. Okay? Some of you will move on and take Calculus 1. And whenever you do, you'll see this appear again whenever you are learning about derivatives. Okay? All right. So given the function, bless you, given the function f of x equals x squared minus 5x, we want to evaluate the following. Okay? We want to find f of x plus h. Now, does this look confusing?
Yes.
Why?
Because you have an H. Plus
You have a whole nother like variable.
We have a whole nother variable. We have x plus h. Try not to let that confuse you. You knew before when I said find f of -1, you knew to take -1 and substitute it in where you saw an x in your equation, right? So now when I ask you to find f of x plus h, I'm asking you to substitute in x plus h where you see an x here, and then simplify. Okay, so let's do that. So f of x plus h is equal to the quantity x plus h squared minus 5 times the quantity x plus h. We're not finished yet. That's just the initial step. What questions do you have about the initial step?
Why did you choose to set it up like that?
Why did we choose to set it up like that? And somebody else said, yeah. So here, if you're finding f of x plus h, this says, understanding function notation, it tells us you take x plus h and you substitute it into f. That's how we read the notation. Bless you.
Thank you.
So what we did was we took x plus h and we substituted it in where we saw an x in our function. What other questions do you have? So now we have to simplify. So to simplify, you have to find x plus h quantity squared, which requires you to do what?
FOIL.
Use FOIL. You got it. So this is equal to the quantity x plus h times the quantity x plus h minus, we can distribute the 5, -5 to get minus 5x. Continue. Minus 5h. Good. Would you like a minute to determine what x plus h times x plus h is? I'll give you a minute. We know that x plus h times x plus h is as you said, x squared plus 2xh plus h squared, because you add your outer and your inner term and you get the 2xh minus 5x minus 5h. Are there any like terms to combine?
No.
No, there are no like terms. So it is what it is. Okay? That's part A. That's part A. It is what it is. That's part A. That's part A.
But you made it seem like it was hard.
No, we're not done. I mean, there's part A. There's a part B.
No, that's what.
There's a part B.
That's it.
I'm breaking it down into steps for you. Okay? You're welcome. So I'm breaking it down into steps because this entire expression here is called your difference quotient. Notice that your difference quotient has part A embedded in it. F of x plus h. Did you boo this?
Big question.
Huh?
Big question.
You booed the question? Wait a minute. This is good stuff. What are you talking about?
That's because you're like that. This is
You don't think it's good stuff?
no.
Oh, it's sexy, baby. It's beautiful. Because
To you.
Yes, because this is connected to something in calculus called derivatives.
No.
Good thing
I'm
I'm
not
not
saying
saying calculus.
There's a whole branch of mathematics
You're good with
that's
calculus.
built on this concept here.
Baby, we can't even get to college algebra.
You
That part.
Listen, you said, can we get through college algebra? Yes.
I said I can't.
No. That type of issue is not allowed in this class. You can get through this class. You will get through this class. You have to put in the time and the effort to make sure that you're understanding, correct? Are you with me? Stay focused.
Yes, ma'am.
Okay, so make sure that you are putting in the time and effort to understand the concepts that we are discussing in class. That looks like making sure you go through your homework, make sure you're going through examples, make sure you're practicing, reviewing notes, make sure you're coming to office hours. We have a math tutorial lab, has hours as well. You have walk-in time for tutoring in the library as well. Take advantage of all of the resources available to you. Trenton Jeffers, who is the Hawks representative, he has additional hours in the evening. His hours are posted on the Math Tutorial Lab door. Take advantage of it. Okay? All right. So, we have f of x plus h. This part, we know, is what we just did. It's all of this. Now, tell me what f of x is.
X squared minus 5x.
Exactly. It's all of this. It's all of that. So now what we're going to do for the difference quotient, this is equal to x squared plus 2xh. Where are we getting this from?
From the
Part A. You got it. Minus 5x minus 5h. And be careful here because we are subtracting more than one expression or more than one term. So what do we need to put here? Parentheses. Very good. And what do we need to put in the parentheses?
X squared minus 5x.
Very good. All over h. Would you like a minute to simplify?
No. No.
Maybe
Yes, you should do this.
Actually, no.
I'll give you a minute because what do you have to do?
Come on. like-
What's the approach?
Distribute the negative.
Let's make sure we're all on the same page. Would you like me to highlight the?
Yes.
Okay, so you can see what we substituted in. Colors agree. Okay, so go ahead and tell me what the approach is.
Distribute the negative to negative x squared and negative 5x.
Good, you distribute the negative, and then what are you going to do?
Combine like terms.
You're going to combine like terms. That's the approach. Go for it. I'll give you 1 minute. Through this. So, whenever you simplify this, in the back, tell me what you did or what you got for your numerator. You distribute the negative and tell me what you got at this step.
Negative x squared plus
Oh, but wait, what?
Oh, I'm tripping.
Oh, go ahead.
X squared plus 2xh plus h squared
Mm-hmm.
minus 5x minus 5h
Good.
minus x squared
Uh-huh.
plus 5
Good. All over?
8.
Very good. Now what did you all do second row all the way across?
From the back.
Say it again.
Second row from the back.
Yep.
Oh, yeah.
Say it again.
Combine like terms.
Combine like terms, and what'd you get?
2xh plus h squared minus 5h.
You said plus or minus?
Minus 5h.
Minus 5h. Tell me what happened to the rest. Or all over what first?
Oh, h.
Very good. Now what happened to all of the other terms? They canceled out. Good. So the x squares cancel out. What else canceled? The 5x's canceled out. And that's what we were left with. Very good. Okay. What questions do you have so far? Okay. So now what did you notice? As I walked around, I heard people say, like, did you want us to go further right now? No, not yet, because you made an observation that told you could go another step. What was your observation? That all the terms have an H in common, right? Good. So now what you do is you factor the H out of the numerator, and when you factor the H, what are you left with?
2x plus h minus 5.
Minus 5. Good. All of that over. And what happens now? Say it loud where everybody can hear you. Can you all hear him?
Yes, he said the H is canceled.
We heard you first.
I love the way you support each other. Yes. And what did you get?
2x plus h minus 5.
Very good. And that is the difference quotient.
Oh my God.
That's the difference quotient. You know the approach. It's possible. I'm not going to tell you what's on the test. Everything is fair game. Everything is fair game. What is important for you to make sure you do?
Do that review.
Do the review and make sure you understand. The more you practice, the more you work on this, the better you will do. Which is why I'm saying you should be studying now, not waiting till this weekend or waiting till next week. You should be doing this now. I posted the review early for a reason. Even without the review, you can prepare.
I've been in the practice of
Say it again.
I've been in the tri-similar
You've been in the say it again? On Hawks? The tri-similar button works well in Hawks, right? Because it's another way of practicing problems. It's very helpful. Questions? What questions do you have? All right, good. So, notation. What did I say? I'll give you a brain break. Okay, you had your brain break. Let's get back to it.
Thank you. Oh my God.
You're welcome. I love you back. Come on. All right. So, the notation F, semicolon. I keep saying semicolon. This is a colon, right? F, colon. We read this as F is the notation F defined from A to B. Okay? F defined from A to B, or F maps A to B. Okay? This is the notation. This implies that F is a function from the set A to the set B. Again, this is read as F maps A to B, or F is defined from A to B. Okay? A and B are what? Sets. Good. A and B are sets. F is your function. A and B are sets. F is your function. So A is the domain. A is the domain of your function F, which is the set of all your what? X coordinates. Good. Your X coordinates. B is the codomain. B is the codomain of F. And what you know as the range of F is a subset of your codomain. It lives inside of it. So if you have, this is your set A, this is your set B, F is the function that maps A to B. The codomain is all of B, and the range is a subset. The range is a subset of it. Not in the middle of it, it just lives inside of it. It just lives inside of it. I just drew it that way. Okay? Go ahead. Wait, no?
So it's like offset. So
Offsetting, what do you mean by?
it's like a toy class, but
It's all good.
it's like a circle inside of a circle.
It's a circle inside of a circle. And it doesn't necessarily have to be in the middle, because remember, we're thinking elements, right? We're thinking elements.
So can it be in or outside, in or around, or it's only inside?
It's whenever we say subset of the set, means it lives inside, so it's in it.
Okay, and is this only for circles?
No, this is not a circle. I'm just using this as a Venn diagram. So really, you have elements. Remember your x coordinates. So if you have 1, 2, 3, the elements here would just be 1, 2, 3. You might have seen this before as Venn diagrams, right? So let's clarify something. So remember I asked you, so this is extra information to answer a question. So remember I gave you a set of pairs. I'm going to give you another set. 1, 2, 3, 4. Not being extremely creative right now, but it's okay. And if I ask you to determine your domain consists of your x coordinates 1, 3, 5, and 7, right? That's your domain. Your range, in this case, is what?
2, 4, 6, 8.
2, 4, 6, and 8. Okay? So notice that over here, I just put that in this set B because it turns out all I gave you was 4 ordered pairs for the set. But it's possible for you to have a function where the domain of the function is the set of all real numbers. The codomain is the set of all real numbers. And if that's the case, and I use this as your function, then this will be the subset inside of all of the real numbers.
So in reality, A and B is like the same number.
No. It doesn't, A doesn't have to be, no, they're not the same numbers, right? Because look,
Yeah.
they're different, right?
Yeah, but you said that like B is the codomain of F, so like.
It's what you're mapping to.
Oh, so is it the range?
The range lives inside of it. It's just another, so the range is a subset of the codomain. The codomain is the entire set B. It's the entire set B. The range is a subset of it. So if I happen to say F, we'll go through an example. Let's do another example. Let's do A to make this clear.
All right.
Okay? Let's do A to make this clear. Are we okay so far pending us going through example A? Okay. So we still need to wrap up your question. So example 5 says identify the domain, the codomain, and the range. Okay? Because there are questions about what's the difference between the codomain and the range. That's the question that you're asking me. So here, what is this notation?
Z.
Z? What does it mean?
Don't know.
The set of integers. The set of integers. Z. Z, make sure you're reading your book. Z is the set.
We have a map.
Mm-hmm. That's what you purchase with this class. You purchase access to your book. And you have it available through Hawks. Your ebook is available through Hawks. Make sure you're reading your book.
Wait, so this is all one, this is still 4.1?
It's 4.1 because I'm taking my time going through it and answering your questions. Now I can go through it a little bit quicker.
Wait a minute now.
But what I'm doing is I'm making sure that you have time to ask whatever questions you have initially, because if you do that while we're going through it, it's going to make sense when you go back through it.
Okay, I thought this was just like a really long chapter.
No, it's not.
Oh.
It's not. It's not at all. It's not at all. Okay? Because all of this ties back to what you learned about a relation and a function. It's connecting everything for a relation, a function, and sets of ordered pairs. It's doing the same thing, just different notation. Remember, we introduced function notation. Now we're tying that function notation to a map. So it's all connected. So Z is the set of integers. Give me examples of integers.
-1.
-1, 3,
0.
0. And you can sum it up by saying you have what kinds of numbers and what kinds of numbers.
Positive and negative.
And
Positive.
positive numbers, negative numbers, and 0. Good. Okay? Good. So you have the set of integers. So G maps the set of integers to the set of integers, and I'm defining G by G of X goes to 3 times X. So, what would be the domain here? Z, right? Good. It's the set of integers. What's the codomain? So, let me highlight it. What's your codomain? Z. Good. And what is your range? You said what? What were you saying? 3x. It's 3x, but x is really a what? A variable. The variable represents what? It's coming from where? It's coming from Z, right? Because here, very good. Let's make the connection. So you have this map from the set, keep writing what I highlighted, from the set of integers to the set of integers. That's Z, that's G, from the set of integers to the set of integers. It's defined by G of X equals 3x. So what this is saying
Is that in between set of integers?
not in between, it's saying you'll take an X, take an element X, and that element, when we talk about elements, we put a bar and then the arrow. I won't use this in class all the time. I'm just using it to help you understand the answer to your question. X goes to 3 times X. So you take an integer in your domain, and then it maps to 3 times X, whatever X is, in your codomain. So you know the codomain is the set of all integers. So -1, -2, -3, 0, 1, 2, 3, and so on. But your range consists of all the, how can we say 3x in words? All the what? Mathematically. What kinds of numbers are we getting? What do they look like? But what specifically do they have in common?
They being multiplied times 3?
They're multiples of 3, absolutely. They're multiples of 3. So really your range looks like multiples of 3. So you'll have numbers, odd numbers, then you'll have -3, then you'll have 0, then you have 3. What's going to be the next one? 6. And then you continue. The 3 dots means it continues. So notice your range is not the same thing as your codomain. You need a minute?
Yeah.
The question is, can you write the range as 3x? Not just 3x. You can write it as the set of all elements 3x such that x belongs to the set of integers. Remember, we talked about that notation last time. Yes.
Will there be times that the codomain is different from the domain?
Yes. Yes. It's possible. You'll see that in the next example. What other questions do you have? So what you learned here in this problem, do you need to see the visual? What you learned here in this problem, this is just another explanation. You took your set A was the set of all integers. Your set B was the set of all integers. And then you're taking the set of all integers, so you're taking -5. Well, I don't have enough space in my domain that I drew the Venn diagram here. So I'll just put -1, 0, 1, and we have other numbers. Okay? And then it mapped over here as well to the set of integers. But our range lives on the inside of the set of integers. It wasn't the entire set. It was only those numbers, those integers that are multiples of 3. So -3, 0, 3, and so on. Does that make sense? It lives inside of it. That's what we mean when we say that the range is a subset of your codomain. It's possible that it can be equal, but in this case it's not. It's just the multiples. We pick out the multiples of 3 from all of the integers. Yes? Oh, you were moving. Okay. What questions do you have? Okay, so let's keep it moving. Here. In part B, G maps the interval 0 to infinity to the set of real numbers. Another way of saying this, all of these numbers here are what? In this interval are? Positive. So it maps the positive numbers greater than or equal to 0 to the real numbers by defining it as g of x equals the square root of x. G of x equals the square root of x. What's the domain?
Bracket 0, infinity.
Very good. The domain is, as you said, bracket 0, infinity, parentheses. What's your codomain? All real numbers. Good. What is your range?
The multiples of the square root of x.
Say it again.
The multiples of square root of x.
Not the multiples of the square root of x.
Or just the square root of x.
Not the square root of x. That's what you're going to get out, but you're looking for how you can characterize those numbers. So if you take a positive number and you plug it in to the square root of x, that number is also going to be what?
Positive.
Positive, right? So that's how we have to write it mathematically. You just summarized it well. So now we need to be able to write that. So it's the set of all x. What does that mean? Such that, good, x is greater than or equal to what? 0, very good. Or, in interval notation, what? What?
Wouldn't it be like positive numbers?
But, how do we write that in interval notation? So how do we write it? What's the interval?
0.
What goes at 0? Bracket, good, as you said. 0, bracket 0, comma, infinity. And what goes at infinity? Parentheses, good. That's it. That's it. That's domain and range. That's domain and range.
So sometimes your co-domain, air domain are the same, and sometimes your range and your domain are the same.
You got it. So sometimes your domain and codomain are the same, sometimes they're different. Okay? So because I do tons of examples, just went through this example that defined what the square root of x was, we knew where to begin. The next page is about domain, but you find it a different way. Okay? So this takes into account that you know part B from the example we just did, from example 5. Here, you have to determine the implied domain. You have f of x is equal to the square root of 2x plus 6, or we can write this as 2x plus 6, that quantity, to the 1/2. Remember, if you have to send a message, go out in the hallway. Okay? So again, if you need to understand why you get 1/2, you can think of that as in parentheses. That's 1, that's 2. Okay? Now, for a square root, as we just said, we know that what's inside always has to be greater than or equal to what? 0, as we just went over. So we know by example 5, that was part B, right? We know that 2x plus 6 has to be greater than or equal to 0. Now we solve this inequality and write it in interval notation. How do we solve it? We've done this a while ago. What do we do?
Move the 6 square.
Do we square this? I heard move the 6. I heard square it. What are we doing?
We saw phrase, right?
Yeah.
Yeah, move the 6.
How?
To the left hand, to the
By
right.
doing what mathematically?
Oh, subtract.
Okay, good. We subtract 6 to get 2.
2x
Is greater than
And now what?
divide by 2.
Good. Does anything happen with the sign?
Yes,
Yes,
it
it
does.
flips. No,
Oh, yeah.
because you're not dividing by negative.
Good. Good discussion. No, we're not dividing by a negative, so the symbol does not switch. So you get x is greater than or equal to?
-3.
-3. Tell me the interval that corresponds to that inequality. I can't hear you.
Is it bracket -3, comma,
Very good, both of you. Yep, very good, both of you. Bracket -3, comma, infinity, parentheses. This is your domain. Not so bad. That's your domain. Okay? It's a lot to take in. It's a lot to take in. I'm here if you need me. Okay? Now let's look at part B. Wait. Yeah? Go, okay. What are we waiting on? You need a minute?
Yeah.
Go ahead.
No. I thought we were doing both of the equations.
We getting ready to do part B. Oh, you talking about this one and this one? Oh, they're the same thing. I just gave you a different way of rewriting it. These two represent the same function. One is just a way to rewrite the other.
Which one do you think would be easier if we do? Okay.
That's what we see already, right? We've seen that before.
You've seen what? The square root function?
Yeah.
The square root function, we've talked about linear functions and everything, so we're introducing different kinds of functions. The graph of the square root function is different, but right now we're not focusing on the graph of this function, we're talking about the domain of the function. And because we, okay? All right, so part B to example 6, you have C of x equals x minus 1 divided by 2 minus x. Does this look confusing?
Yes.
Okay, tell me why it looks confusing. Because it's a fraction? It's a rational function? Rational function? Okay. Any other reasons? What do we know about rational functions? The denominator what?
Has to be greater than 0.
Can you all hear her in the back?
Yes.
They're shaking their heads. No. Say it again.
Denominator has to be greater than 0.
Did you say the denominator has to be greater than 0? Does the denominator have to be greater than 0?
What?
Does it have to be greater than 0? For a square root function, the radicand has to be greater than or equal to 0. But think about a fraction with numbers. Does the denominator always have to be greater than 0?
No.
No. So here, our denominator does not have to be greater than 0. What do we know about fractions? Your denominator, what do you know about your denominator? I can't hear you. I can't hear you. Multiply what? What are you thinking? What are you trying to do?
Get rid of your denominator.
Oh, that's not what we're doing here. We're not, so that's why I asked what were you thinking? Because here, if you're trying to get rid of your denominator here, that's not our goal. Our goal is not to solve for anything here. Our goal is to determine what the domain is. So we want to figure out what type of x values are possible for this function. Does that make sense? Okay, so with a fraction, what do we know about the denominators of fractions?
They're on the bottom.
Yeah, they're in the bottom. They're the denominator. Can we put any kind of number there?
Yeah.
Oh, so we can put 0 there? You're saying, yeah. Can we put 0 there?
No, because we're not going to get anything.
What do you mean?
You could put 0 there, but like
We're
it's
not
gonna
trying to
equal
solve. Never
0.
mind.
Oh, if you divide by 0, you get 0? That's a question. If you divide by 0, do you get 0?
Yes.
No. What do you get? You get what? Marquise, what did you say? You get the number? So what you're telling me, so you're telling me if you take -1 divided by 0, this is a whole question for me to you. You're saying if you take -1 and divide it by 0, I heard some saying you're going to get 0. I heard some saying you're going to get -1. What? I can't hear Greg. Yeah. What'd you say? You can't divide by 0. You cannot divide by 0. Why? Say it again. It's impossible. What happens when you divide by 0?
You're slow.
You get an undefined solution. It's undefined. So we cannot divide by 0. So it's undefined. So this is not okay. We cannot divide by 0. Are we all on the same page right now?
Yes.
All of that to say, if we have this rational function, we know our denominator cannot be what?
0.
Okay. Oh, you made the connection. Excellent. So go ahead. What?
It's gonna be x minus 1 over 2 minus x. It has to be greater than 0.
No, it doesn't have to be greater than or equal to 0. So the question was, is your it domain?
Yes.
So it was that you were saying that the domain is going to be this function where x is greater than 0. That's not true. That's a good attempt. But let's zoom in on what we know about x. We know here that our denominator cannot be 0. Anything in our numerator, any x value in our numerator is all right. But our denominator has restrictions. So we can have the set of all x such that 2 minus x does not equal what? 0. And then we have to write this out. Well, this means the set of all x, if we solve this portion here, that means that 2 is not equal to x, right? So that means the set of all x such that x does not equal 2. We added x to both sides of this.
Yeah.
Yes.
So if it's the set of all x such that x cannot equal 2, then every other number is fair game.
How come you didn't move it to instead of that?
You can, whatever makes you happy. You can move the 2 to the right-hand side, and you'll get negative x equals negative 2, but then you have to divide both sides by
Negative 1.
-1, and you'll get the same thing.
Okay.
That's fine if you take that step or take that approach. So we get that our domain is all the numbers negative infinity to 2 union 2 to infinity. We do not have brackets at 2 because we said x cannot equal 2. What questions do you have? What questions do you have? What questions do you have? Okay. So this is section 4.1. Section 4.2 is 2 pages. Wait a minute, we got 2 whole minutes. We got 2 whole minutes. So yes, we're gonna move on to section 4.2. Section 4.2, we've really done already. Okay, this is formally discussing it. Okay, questions here?
No.
Okay.
Somebody